Hi everyone, I am Soumojit Chatterjee and welcome to TLE Eliminators. This is the post-contest discussion of today's Codeforces Div 2 contest. So I hope you all had a fun contest and we will discuss the first four problems A to D in today's PCD. So before moving forward, I would just want to clarify whether I am completely audible and visible or not. Can someone quickly confirm in the chat? Hello guys, am I audible? Thank you. Okay, so before we start, I would just want to tell you about the newly launched version of our TLE's CP31 sheet. So for any one of you who is not aware, so this is basically a set of 31 handpicked problems in each rating range 800 to 1900 from Codeforces. Here you can also connect your Codeforces handle. So it will help you to see what is your progress on the CP sheet. Apart from that, there is a dedicated discuss section where you can discuss your doubts, and you can also have yourself on the leaderboard where you can check with your friends where do you stand and what is your progress on the sheet. Apart from that, every week 7 to 8 solutions of these problems will be posted. So you do not need to waste time searching for a good set of problems or solutions, and you can actually have a practice from here and improve and enjoy competitive programming. So that's all for it. Let's start today's PCD. So here is the first problem of the contest. The question says final verdict. The question is that you are given an array A of length n and you must perform the following operation until the length of A becomes 1. Okay, so what is the operation? It says that choose a positive integer k which is less than the length of A such that mod A by k is an integer. Okay, and then split A into k subsequences S1 to Sk such that each element of A belongs to exactly one subsequence and the length of every subsequence is equal. Okay, it says that after this replace A with the average of all these subsequences, and the task is to determine whether there exists a sequence of operations such that after all operations A is x.
200 बार हमें 200 में होके कहते भाई
Let me mute everyone just a second. Yeah, so let me explain the problem statement first. So the question says that in input we will be given some array, right? So we will be given some array A as input. So for example, say A is 1, 2, 1, 1. Okay. So we will be given some array A as input. Now, what do we need to do? It says that at every operation, you can choose some sequence, some integer k, which is basically the number of subsequences. Okay, that is your choice. So let me choose k equal to 2. Now, we need to break A into two subsequences of equal length. Okay, so since the length of A is 4, and I have already decided that I will break A into two subsequences, the length of each subsequence will be 2, right? So suppose this is one subsequence, I choose this one and this one. Okay, so the first subsequence I get is the subsequence 1, 1. And the second subsequence, which is basically the remaining elements, is 2, 1, right? Now, compute their average. So what is the average of the subsequence 1, 1? It is 1 itself. And what is the average of the subsequence 2, 1? It is 1.5, right? Now it says that you concatenate these numbers to create your new array A. So this was your old array A, right? So my new array A, so let me call that new A. That will be basically this new average array. So I have 1 and then I have a 1.5. Okay. So now at every operation, what do you see? The length of the array decreases, right? From you initially had an array of 4 elements. Now you have an array of 2 elements. Okay. So keep on doing this operation. To choose whatever 2 k you need. and then keep on doing this operation. Finally, you get an array which has only one element, right? So finally, the length keeps on decreasing and becomes 1. The question is, can we ever reach? So the question is, can we ever reach a single array which is basically this array X, where X is also a part of the input. So X is, don't worry about X, X is given as input. And the question is that does there exist a sequence of operations such that you finally reach to this singleton array X? Okay, so is the problem statement clear? Anyone, any doubts with the question? Guys, give a quick yes if you feel that there are no doubts, so I could proceed. Okay, thank you. Thanks, Abhinav. Okay, so if the problem statement is clear, so what are we basically doing? There is one more important condition that if you look at the problem statement. So if you look at the problem statement, look at these two conditions, that each element of A belongs to exactly one subsequence and the length of every subsequence is equal. Okay, so these are two important conditions. Okay, so now observe this simple invariant. So this is an invariant which is like, which comes pretty handy whenever you basically come up with this average. So what is an invariant here? So what do I mean by an invariant? An invariant means something which does not varies. So something which does not change. So I had some array A, right? And I did some weird operation on it to get an A dash. So what is that one thing which did not change when I transformed A to A dash? So my claim is that the average of the array is the invariant. So I'm saying that the average of the array does not change. So whatever the average of the array A be, same is the average of the array A dash. Just for an example, what we did initially, we had this array 1 to 1, 1, right? And we did some operation on it to convert to it to 1, 1 and 1.5. Look here, what is the average of this array? The average of this array is basically the sum of the elements 1 plus 2 plus 1 plus 1 divided by the number of elements, which is 4, which is 1.25. Fine. And what is the average of these two elements? It is 1 plus 1.5 by 2. And it also comes as 1.25. So that means whenever you do an operation and you convert the array A to A dash, the average does not change. This is my claim. Okay. And we saw an example where it satisfies. Okay. But let us try to prove it a bit mathematically. So what we did, so we had an array A. Suppose its length is n. Okay. Its length is n. And suppose that its sum is s. So its sum is s. Fine. No doubts. Now, we broke A into subsequences S1, S2, dot, 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 Sk, right? So these are the subsequences where we broke. And let's suppose that their sum be small s1, small s2, and it goes on till Sk. Okay. Now, what is the average of this new array A? The average of this new array is sum capital S divided by the total number of elements n. So it's capital S by n, right? And what is the sum of this new, what is the average of this new array? So this new array is basically the array of the averages, right? So it is S1 divided by its length. Now what is the length? You broke an array of length n into k parts. So that means the length of each part is n by k. Okay. So the elements is S1 by n by k, S2 by n by k, and so on. And it goes on till Sk by n by k. Okay, fine. So what is the average of this array? So if I try to find the average of this array, so the new average is basically the sum divided by the total number of elements, right? So the sum is S1 by n by k. So let me call that S1 by n and let me take a k common outside. So it becomes like this, S1 by n plus S2 by n, and it goes on till Sk by n. And what is the total number of elements? That's k, right? So that divided by k. So how beautifully this k cancels out. And the sum of all these S1, S2, and Sk is nothing but the total sum of the array. So it is S and it is S by n. So that means the new average is S by n. But we already noted that the old average is also S by n. That means whenever I do an operation, we have formally proved that the average does not change. Great. So if the average does not change, that means now what was the initial question? That I had an array A of length n, and I need to do some operations and I have to convert it to an array of single length of length 1, which is x. So what is the average of this array? It is x itself, right? So that means it is possible only when the average of A is x. Okay. So what will I do? So the algorithm is simple. Compute average of x. So what is compute average of x? Of A. What is average of A? Average of A is nothing but its total sum divided by n. And check, is it equal to x? Is it equal to x? If it is equal to x, then you print a yes. Otherwise, you print a no. Okay. So let me show you the code once. So the code is simple and implements the exact same thing. You take n and x as input, you take the vector as input, and then you compute the sum of the array. Okay. And then you just check, okay, is S is equal to the product of n and x. Why product? Because basically writing this same thing as is sum equals to n into x. So the n goes here. Okay. So if this equality holds, then we print a yes, otherwise we print a no. Straightforward. Okay, so any doubts? Guys, is the solution clear?
So just need a short recap.
Okay, Vinod. So basically the idea is simple. Like whenever I do an operation, so the basic idea is that there is an invariant here. What is the invariant? That if I have an array A, and I do an operation to convert it to A dash, the average does not change. Okay, you can take some examples on pen and paper, and you can see that the average does not change. Also, if you do a bit of math, you will quickly realize that the average remains the same. So that means if the average does not change, and I have converted the big array A into an array of single element, which is x, that means the average of the new array must be x. If the average of the new array is x, then it is possible to convert. Otherwise, it is not, because it will break the invariant. So that is the reason we simply compute the average of the array and then check whether is it equal to x or not. If it is equal to x, we print a yes. Otherwise, we print a no.
Yeah, understood, sir.
Okay, great. Okay, Naivedyam, we will not discuss E. We will discuss till D in today's PCD. Okay, great. So if that's clear, let's start with problem B of the contest. Okay, so this is the second problem of the contest, and it is as follows. So the question's name is Vicious Labyrinth. It says that there are n cells in a labyrinth, and cell I is n minus I kilometers away from the exit. Okay, so in particular, cell n is the exit. Note also that each cell is connected to the exit but is not accessible from any other cell in any way. So in each cell, there is initially exactly one person stuck, and we want to help everyone to get as close to the exit as possible by installing a teleporter in each cell I, which translocates the person in that cell to another cell AI. Okay, but the labyrinth owner caught you in the act. Amused, she lets you continue, but under some conditions. Okay, so what are the conditions? Everyone must use the teleporter exactly k times. K is given as the input. And no teleporter in any cell can lead to the same cell it is in. Okay, so formally I is not equal to AI. Great. Now the question says that we must find a teleporter configuration that minimizes the sum of distances of all individuals from the exit after using the teleporter exactly k times. And if there are many possible configurations, we need to output any one of them. Okay, great. So let me explain the problem statement once. Okay. So this is question B. So the input says, so the input is simple. They will give us two integers n and k. Okay. So what does the question says? The question says that you have a labyrinth. So that is basically you have a labyrinth like this of n cells. Okay. So there are n cells. So let me number these cells from 1, 2, and it goes till this is n minus 1 and this is n. They call the nth cell to be the exit. Okay, fine. And the question says that there is exactly one person who is stuck at every cell of the labyrinth. Okay, so at every cell of the labyrinth, there is exactly one person who is stuck. Fine. Now, what do we need to do? The question says that we need to install a teleporter at every cell. So at every cell, I will install a teleporter. So basically at every cell, I will give some integer a1, an integer a2 here, and then it goes till an minus 1 and an. So what is the significance of this integer ai? So whenever I assign an integer a1 to the first cell, that means I have installed a teleporter which helps the person teleports from cell number 1 to cell number a1. So suppose this is the a1th cell. So it helps the person to teleport from cell number 1 to cell number a1 directly in one move. Okay. So the question says that you need to install n teleporters a1 to an in each of these cells. Okay. So how should I install these teleporters? What is the objective? The objective is simple. An integer k is given as input, and it is said that every person will make k teleportations. So whatever k be, every person, depending on these integers ai, every person will make k teleportations. Okay. So after making these k teleportations, depending on what ai as I give as output, this person reaches some position here. Okay. Now the question says that we need to minimize the final sum of distances of every person from the exit. Okay. So suppose finally all these people reach some cells like this, we need to minimize the sum of their distances from the exit. Okay. So that means we need to push every person as close to the exit as possible. Okay. So that is how we need to install the teleporters. So we need to finally output one configuration of these teleporters that basically means this array A of n integers such that the final sum of the distances is minimized. So is the problem statement clear? Is the question clear? Aniket, we will come to the solution. But is the question clear? Okay, great. So if the problem is clear, so my initial idea is, so what should we need to do? Think about this, that I need to ensure that every person reaches to the exit as close as possible, as fast as possible, right? So in k moves, I need to ensure that every person reaches the exit. Okay, fine. So what my initial thought is, okay, there is one more condition which the problem says which we need to enforce. Okay, and that is ai cannot be equal to I. That means you can't say that, okay, I'm standing at this cell, I teleport to the same cell back. This is not allowed. So this is not allowed as per the problem. Okay, fine. So now what will you do at this an? Because at the final objective is that we need to keep things as close to the exit as possible. But we cannot have a self loop here, right? So that means we cannot assign n to this final cell. So what should we assign to the final cell? So any idea? What should be optimal to assign at the final cell? We cannot assign n there, right? Because that would violate the condition. Yes, exactly. So as Sandeep says, it makes sense. It always makes sense to assign an equals to n minus 1. Okay. Why an equals n minus 1? Because we need to things as close to the exit as possible. So why not just keep it to the nearest cell to the exit? I cannot keep it at n. Okay, let me keep it at n minus 1. I should not push it farther away from the exit. So that is the nearest cell to the exit. So that should be fine. Okay, great. Now when I was solving the problem in the contest, my initial idea was simple. Okay, so I had these cells. So I had this labyrinth, and then there are cells like this. So my idea was simple. Okay, here, if I'm standing here, I have to jump back here. There is no other way. Now, since I need to keep things as close to the exit as possible, does it not make sense to make all other cells jump to the exit? Why not make all other cells jump to the exit? That would not violate any condition, right? So that would not violate any condition. For all ai not equal to I would be satisfied. And since everyone jumps to the exit, like the distance to the exit should also be minimum. So this was my initial idea, but this would actually fail. So this would actually fail. It would give a wrong answer. So can anyone understand why? Like why pointing everyone to the exit directly may give a wrong answer? Okay, so let me explain. So the basic problem is, what if k equals 2? So suppose going by our previous plan, we did something like that. Okay, so as per our previous plan, what we did, we marked this nth cell to n minus 1, and remaining all other cells basically went to the final exit. So that was our plan. And suppose we implemented it. Now, suppose the value of k, which is given in the question, is 2. Okay. So suppose the value of k given in the question is 2. So what will happen? Every person, look at every person. At every person in his first step will reach to the exit, right? But then in the next step, it will jump back from the exit to the previous step, to the previous cell. So that means every person except the one on the exit will finally reach the second last cell. That will not minimize the distance, right? We could have done better, but we compromised it by so that every person finishes the second last cell and not the last cell. We did that because that happened because we pointed every cell to the exit. So in one step we reach the exit, but in the next step we need to move back from the exit to the previous cell, and that is the reason the problem happened. Okay, so what can be a plausible solution? Yes, exactly, Sandeep. Like the configuration which you said, that is the reason it is wrong. Because suppose the value of k is 2. If the value of k is 2, then every person first reaches to n in one stage, and in the next step, it jumps back from to n minus 1. So every person finally reaches n minus 1. That is not optimal, right? We could have done better. Let me show how can we do better. So suppose this k equal to 2. So this same example, k equal to 2, what I could have done, like, don't you think? So suppose this is the case, and it goes still here. Don't you think that since the value of k equals to k is 2, so here we have no choice. The last cell goes to n minus 1. But since the value of k is 2, so let me make this n minus 1 go till n, and every other person go to this n minus 1th cell. Now you will ask me, what is the benefit here? The benefit here is simple. Look at some random person who starts at some other cell. So suppose look at this first person. In the first operation, he goes to the second last cell. Okay. And since the value of k is 2, in the next step, it goes to the final cell. So that means every person here in k equal to 2 steps finally reaches the final cell. So that is more optimal, right? In the previous step, the problem which happened was we pointed everyone to the final cell. So in the next step, they were coming to the second last cell. But here, we smartly pointed everyone to the second last cell, and then in the next step, we make it move to the final cell. So this one is a better solution, right? So do you understand, like, where is the catch? Like, is it clear? Okay, so the idea is simple. So here is the algorithm. So let me propose the algorithm first. Like, what should be the solution? My solution is simple. There are two cases. The first case is, suppose k is odd. If k is odd, what will I do? If k is odd, my idea is simple. So I have this labyrinth, and k is odd. So I have this large labyrinth, and it goes on. The last cell has to move to the second last cell. So the value of an is n-1. We can't do anything else. And rest all, what will I do? My idea is simple. For rest all other indices ai, I will mark it to n. So that is for all other indices, I will mark it to the final index. So why does that work? Because the value of k is odd. So suppose the value of k is 3. Look what actually happens. So if there is a person here, and if the value of k is 3, after the first step, it reaches the final cell. After the second step, it reaches the second last cell. And since the value of k is 3, it will again go back and finally reach the final cell. So that is the advantage we get when k is odd. When k is odd, at one step, let it move to the final cell, and then it will move back and forth and finally end up in this final cell. My objective is simple. I want more and more people to come and reach the final cell. Okay, so since k is odd, it will not create a problem. So every person will first reach the final cell, then it will move to the second last cell, and then it will again go back to the final cell. Okay, great. And what if k is even? So if k is even, now pointing everyone to the final cell is a problem. So now I will do something different. If k is even, then here though I have no choice. Here it is simple. I mark an again as n-1. I can't do anything else. Okay. But now, for all other cells, I pointed to the second last cell. So for all other cells, I pointed to the second last cell. And this second last one, I move it to the last. So what is the advantage here? So for any other guy who stands at some other cell, it will first move to the second last cell, and then it will move to the last cell. And then since k is even, it will again move back and forth and finally end up at the last cell. If k is even, our initial solution for k equal to odd would not have worked. We would have ended up in the second last cell, which would be suboptimal. So that is the reason we make it point to the second last cell first and then move it to the last cell, so that we finally end up at the last cell itself. So is the solution clear? Yes, Aniket, we can say that. Independent of k, we can always put the n-1 person at exit cell. That is fine. Because if you look at the solutions, then in both these cases, independent of what k is, even if k is even or k is odd, the nth person moves to the n-1th person cell, and the n-1th cell moves to the nth cell. Okay, here also, at least this part remains the same. But for all other people, the condition varies. depending on the parity of k. So is the solution clear? Any doubts at any part of the solution? And if it is clear, then okay, great. So let me quickly show the code. So here is the code. I take n and k as input. If n is 2, then I handle it separately, because if n equal to 2, that's basically an edge case, because then there are only two cells, and 2 and 2 1 is the only configuration, because you need to ensure that ai is not equal to I. So at the first position, you can't keep a 1, you have to keep a 2 there, and in the second position, you have to keep a 1 there. So this is just a simple edge case. Apart from that, the idea is simple. If k is even, then I mark every one at n minus 1, and the second last one marks at n. And if k is odd, then I mark every one at n, and the second last one marks at n minus 1. And finally, I print the array A. So I hope it's clear. Okay. Just give me a second. We will resume within a minute. Yeah, so sorry for the delay. Can anyone quickly confirm I'm audible, right? Okay, great. So let's start with the third problem of the contest. So this is the third question of the contest. The question's name is breach of faith. So it says that you and your team have worked tirelessly until you have a sequence a1 to a2n plus 1 of positive integers satisfying these properties. Okay, so what are the properties? Every ai lies between 1 till 10 to the power 18. Fine. A1 till A2n plus 1 are pairwise distinct. That means all integers are distinct. There is no duplication or repetition in them. That's fine. And this is the third condition. Let's look into it a bit later. So what does the question says? The question says that, however, the people you worked with sabotaged you because they want to publish the sequence first. They deleted one number from the sequence and shuffled the rest. So that leaves you with a sequence B1 to B2n. You have forgotten the sequence A and want to find a way to recover it. Okay. If there are many possible sequences, you can output any of them, and it can be proven under the constraints of the problem that at least one such sequence A exists. Okay, great. So let me explain the problem statement once. So the question says that you had an array A. Okay. So you had an array A which satisfied some constraints. What are the constraints? The first one is trivial, that every ai lies between 1 till 10 to the power 18. So they are positive integers. Great. The second one says that ai is not equal to aj. So that means for all I not equal to j. So that means if I have two distinct indices I and j, their values are not the same. So they are pairwise distinct. Fine. The third one is a long expression which if you rewrite becomes like this. It says, okay, so just reminding you, this A was of length 2n plus 1, right? So it has an odd length. So the third condition is something like this. It says that A1 plus A3, and it goes on till A2n plus 1. This is basically equal to A2 plus A4, and it goes on till A2n, right? So that means the question says that the sum of all integers at odd indices is equal to the sum of all integers at even indices. So we can also call this condition in short that sum of all these odd indices is equal to the sum of integers at the even indices, right? So you had an array A, but the question says that you have lost this array A. So this array A is lost. Basically, you need to finally print this array A only. Okay, so how can we recover this array A? The question says that you are given an array B of length 2n. Okay, so basically from this array A, one element is deleted. Any one element which we do not know which element is deleted, and the rest of the array is shuffled. And the rest of the array is shuffled, and you are finally given this array B. From this array B, you have to somehow recover back A and print A. Okay, so that is the idea. You have to recover A and print it. So that is the basic question. So is the problem statement clear? Any doubts with the question? Okay. Aniket, what is significance of pairwise distinct? Like, there is no significance, right? Like, that's the problem statement. So the problem statement says that things are pairwise distinct. That means it's a bunch of all unique numbers. Okay. And let me read, okay, the third condition. So if you look at this expression, if you look at this expression and all these numbers which have a minus sign in front of them, take it to the left hand side. Okay. So if you take it to the left hand side, the condition becomes something like this. What does the condition becomes? The condition becomes A1 plus A3 plus A5, and it goes on till A2n plus 1. This sum is basically equal to A2 plus A4, and it goes on till A2n. What I was saying is, like, look at this sum. What is this sum? This sum is basically sum of all integers at odd indices, right? What is A1? A1 is at index 1. So that is a odd index, right? So all of these are odd indices, and all of these are numbers at even indices. So let me show you an example. Suppose I have an integer. Suppose I have an array 1, 9, 3, 5, and say 10. Okay. So now tell me, what is the sum? What is the sum at odd indices? Sum at odd indices. So what are the odd indices? So if I index them, so let me index them. So this is the array, right? Okay, let me erase this part. So this is the array. If I index them, this is at the first index, this is at the second index, this is at the third index, this is at the fourth index, and this number is at the fifth index. Okay. Now, what is the sum of the numbers at odd indices? So this is an odd index, this is an odd index, and this is an odd index. So the sum of the numbers at odd indices is simply 1 plus 3 plus 10. So what is that? 14. Right? So similarly, what is the sum at even indices? What is the sum at even indices? It is simply 9 plus 5, right? So it is 9 plus 5, that is also equal to 14. So that is what the third condition is. All the sum of all the numbers at even indices is equal to the sum of all numbers at odd indices, which you can also basically think about it like, okay, the alternating sum is equal. So from 1, you keep on alternating one position and find the sum. So that is 14. And from 9, you keep on alternating one position and find the sum. That is also 14. So both these sums should be the same. That is the third condition for A to satisfy. So is that clear? Okay, great. Okay, great. So if the third conditions are clear, so think about this. I have this array B, right? I have this array B where exactly one integer is missing. So I have this array B where I have two integers and exactly one integer is missing. And I don't know which one is missing. One is missing. And I need to finally construct A. Okay. But think about, okay, so I need to finally construct A. So that means what should I do basically? That means I need to make two bags. I need to make two bags of integers. Let me call this bag 1, B1, and let me call this B2. I need to make two bags of integers. The first bag should have n plus 1 size. And the second bag should have n size. I should make these bags in such a way that their sum are equal. Now you will ask me, what is the benefit if I construct these bags? Basically, if you can construct these two bags B1 and B2 such that their sum is equal and B1 has a size of size n plus 1, B2 has a size n, then basically array A is already constructed, right? How is array A constructed? You simply take one element from here, from B1, and then one element from B2 and keep on alternating them and print as A, right? For example, like you can think every array. So we got that array, right? Like we had 1, 9, 3, 5, and 10. We already saw that both sum at odd indices and even indices here is 14. You can think this array as two bags. One bag contains the integers 1, 3, and 10. The other bag contains the integers 9 and 5. Look that their sum are equal. So their sum is the same. And apart from the fact, this bag has size n plus 1. This bag has size n, right? This is an array of length 2n plus 1. This bag has size n plus 1. This bag has size n. So that means if I can construct two such bags, one of size n plus 1, other of size n, such that their sum is equal, then I am basically done. Okay. So is that clear? No, Naivedyam, this is, I did not think this is harder than a normal diff2C, probably just a bit of observation. Okay, but up to this, is it clear? Like, is the objective clear? We need to make two bags, one of size n plus 1, the other of size n, such that their sum are same. And then there is one more condition. What is the condition? That I need to keep all of them distinct, right? Like in this bag, all these integers are distinct. So I cannot just take one integer and put it in the bag. I need to also ensure that all the integers are distinct. So if there is some integer already present, I cannot put one more integer in the bag which is already present. So that would violate the condition that A is pairwise distinct. Okay, fine. So now here is the solution. So here is the solution. First of all, note that the order in B is not important, right? The order in B is not important. Because at the end of the day, what we need to do is we need to construct the bag, right? So whenever you are constructing bags, like how is the order important? You can anyway shuffle the order and still print the integers as A, right? So the order is not important. So let me sort it. Okay. So let me sort A. So I'm sorting A. Sorry, A is not present. So let me sort B. B is an array of 2n integers. Let me sort them. And finally, suppose the integers which I have got is this. It is B1, B2, and then I have B2n. Okay. And now from here, I need to construct two bags, one of size n plus 1, other of size n, such that their sum are equal. Okay, fine. And I also need to ensure that the extra integer which I add, I have 2n integers already present, that is given me in the array, that is given to me in the array B. I need to add one extra integer to make the array A, right? So that means I need to add one more extra integer. While adding, I need to ensure that that integer is not present among all these integers. Otherwise, duplication will happen. So that is the major challenge of the problem. Otherwise, you could have easily picked one integer to maintain the equal sum, right? But how will you do it so that you also ensure that there is no duplication? Okay, so my idea is simple. So let me write this. So I have these integers b1, b2, b3. It goes on till bn, and then I have this bn plus 1, bn plus 2, and then it goes till b2n plus 1. This is the sorted order, right? So let me call this b1 as low. So let me call this b1 as low and b2n plus 1 as high. Fine. So b1 is low, b2n plus 1 is high, and this is sorted order. So basically every bi is less than equal to bi plus 1. No, not even equal to, because it has been given that the integers are distinct. So bi is strictly less than bi plus 1. That we know. Okay, fine. So now let me construct the two bags. Okay. So here is how I will construct the two bags. So this is my bag b1. This is my bag b2. Fine. So my idea is simple. Take all these n-1 numbers, put it in bag b1, and take all these n-1 numbers again, put it in bag b2. So I'm leaving low here, I'm leaving high here. So low and high I have not touched. b1 I have not touched, b2n plus 1 I have not touched. But all these numbers I've put it in the bag b1, and all these numbers I've put it in the bag b2. So now b1 contains the integers b2, b3, and it goes on till bn, and b2 contains the integers bn plus 1, bn plus 2, and it goes on till b2n. Okay, so what is the size of b1 and b2 at till this moment? Yeah, Ritvik, up to what I have done till now, they are distinct, right? Because the array integers in the array b are distinct. There, it is already given to us. So up to what I have done, that is clear, right? So can anyone tell me what is the size of bags b1 and b2 up to this moment? Anyone? How many integers I have inserted in the bags b1 and b2 up to this? n-1, right? Look what I've done. I have inserted everything from b2 to bn in one bag. So that is n-1 integers. So I have inserted n-1 integers in bag b1. I have also inserted n-1 integers here. Right? Sorry, just a second. This is b2n. B is an array of size 2n, right? We have to construct an array A which is of size 2n plus 1. So we need one new integer which is not present in any of these. Okay, so this would be b2n minus 1. So I have b1 of size n minus 1. I have b2 of size n minus 1. Okay. So can anyone tell me which one of these bags b1 and b2 is heavier? Like which one has a larger sum till this moment? Like which one has a larger sum? Exactly, b2 has a larger sum because this was a sorted order. Bn plus 1 till b2n minus 1. All these integers were larger than b2, b3, and bn. So that means this should have a larger sum. So suppose the weight of this bag, the sum is greater than s. So up to this moment, the weight of this bag is greater than s by b2. So that means, so I'm basically saying that up to this moment, sum of b2 is sum of b1 plus s. Okay. Remember the final objective. We need to make the sum of all these integers equal. Okay. So we need to make the sum of these two bags equal. But till this moment, the bag b2 is heavier. Okay. So now what is my plan? My plan is let me put both low and high in B2. So again, what do? I put low in B2 and high in B2. Both low and high come in B2. Okay. So that is my idea. Both low and high are here in B2. So now I have added 2 more integers in B2. So the size of B2 has become n plus 1. Okay. So now, in order to balance the sum, what value should I put here? Remember that the size of B2 has become n plus 1, but the size of B1 is still n minus 1. So I need an extra integer here. So what value should I put in B1? Any idea? S, exactly, S plus low plus high. So now, since I have to balance the sum, I have to maintain both the sum to equal values. Just a second. Just a second, guys. I'm facing some problem with my pen. Yeah, so let's start. Sorry for the disruption. Yes, Naivedyam, S is the difference of weights. So basically up to this moment, like what was S? So let me formally write what is S. S was basically, it was B2n minus 1 and it goes on till Bn. So these values minus Bn n minus 1 and it goes on till B2. So this was our S. So that is basically before adding low and high, what was the initial difference of weights? So before adding low and high, I said that, okay, B2 was S heavier than B1. Okay. So B2 was already S heavier. I again inserted low and high in B2. So it is now S plus low plus high heavier, right? So now, since I have to balance the weight, I have to insert an S plus low plus high here. Okay. So now the size of B1 becomes N, the size of B2 becomes N plus 1. Okay. So now what remains to argue is that S plus low plus high, this is not present in B. Can someone give an argument or tell me why is it not present in B? Like why should it not be present in B? Because if it is present in B, then the solution fails, right? Because then we get duplicate elements. Like we have already constructed 2 bags, one of size n, the other of size n plus 1. But the new integer we added is S plus low plus high. Exactly. As Ashwin pointed out, because this new integer which we have added is S plus low plus high. Now S is something positive. So S is positive. Low is also something positive. And then we have high. So it means S plus low plus high is already larger than the largest element present in B. So that means S plus low plus high is larger than this B2n. So that means it is larger than all the elements present in B. So that means it should be distinct or a unique element in this bag. Okay. So finally, we are able to construct 2 bags B1 and B2, one of size n, the other of size n plus 1, such that they all have distinct elements. So now we can simply print A. So how will we print A? I already have 2 bags B1 and B2. B1 is of size n, B2 is of size n plus 1. Simply start from B2, take one element from B2, print it. Then take one element from B1, print it. and then again take one element from B to print it, and keep on doing it unless both the bags are empty. Okay, so let me show the code, and then we will come at any doubts which you people have. So here is the code, straightforward, simple enough. I take the array A, sorry, I should have named it B, as to maintain the same convention as the explanation. But then we sort it, okay? And then from I equal to 1 till n, I basically insert G in the same order. So instead of, so I said bags just for explanation. So I am maintaining G where I will print it. So basically I, in the alternating order, keep on inserting elements AI and then AI plus n minus 1. So that's basically inserting A1, then AN, A2, then AN plus 1. And I keep on like also maintaining like what is the difference. So that I maintain S, and then I finally insert S plus A2n minus 1 plus A0. If you see clearly, like a bit carefully, you will understand this is nothing but S plus low plus high, as we already discussed. And then we simply insert low plus high in one bag, S plus low plus high in the other bag, and we finally print the answer. Okay, so any doubts? Okay. Okay, so there's a doubt like how can we tell it will be less than 1E18? Like if we look in the problem statement, you will realize that BI is given less than equal to 10 to the power 9, right? So even if you like S plus low plus high, that is basically adding up the differences and like adding up the differences and the sum of low and high. So that would never exceed the sum of the array, right? So it should not never exceed like 10 to the power 14 at max. Like it will never exceed 10 to the power 18. That's too large, right? So that would never create a problem. Okay, Akshay, let me explain it once again. But Naivedyam says we added low plus high, so low and high are individually lost in A, right? And every element of B must be in A. Yeah, so every element of B is already in A, right? Look what we did. So if you think about, if you look at the construction of the bags, look that every element of B has been added to A. All these integers B2 to Bn has been added in this bag B1, right? So look, all these integers B2 to Bn has been added in this bag. All these integers Bn plus 1 to B2n minus 1 has been added in this bag. Low and high has been also added in this bag. That means we have already covered all elements of B into these two bags. These two bags of B in union contain all the like these two bags B1 and B2 in union contain all the integers in the array B. Apart from that, we have added one new integer, S plus low plus high. That's it. So, okay, so before discussing further, let me explain it once more as Akshar asked to. So Akshar, you said that the solution was clear till the part I inserted B2 till Bn here and Bn plus 1 till B2n minus 1 here, right? Fine. Till B2n minus 1 here. And I said that, okay, since this is my bag B1, it is of size n minus 1. This is my bag B2. This is of size n minus 1. I said that, okay, since I've inserted large elements in bag B2 compared to B1, so its weight supposes more S more. So suppose the bag of sum of bag B2 is S more than the sum of bag B1. Okay. So now my plan is there are two integers left, low and high, which is basically B1 and B2n. So my idea is insert both low and high. So insert both low and high in the bag B2. Okay. So its sum was initially more than S. So now it becomes S plus low plus high more than B1, right? Because I've also inserted low and high. So in order to balance this, I insert one more new integer, S plus low plus high here. So if I do that, basically the sum gets balanced. The sum of bags B1 and B2 becomes balanced. And now I've inserted two more integers here. So the size of bag B2 becomes n plus 1 and the size of bag B1 becomes n. Okay. And we have already argued that S plus low plus high is already larger than all elements in B. So it will not create a problem with the distinctness. Okay. So is the solution clear? Naivedyam, I hope your doubt is resolved. Okay, great. Okay, so you're asking which bag will contain A1. So either array A is lost, right? We do not know which bag contains A1 and we are not concerned with it. We need to print the array. So what we do is we construct the two bags B1 and B2. Now, obviously, since the bag B2 is of size n plus 1, it is of one size larger than B1. So when you will start printing, you have to start printing from B2 because it is of larger size. So you pick one element from B2, then you pick one element from B1 and then so on. So I hope it's fine and all doubts are resolved. So let's discuss with the last problem of the contest. Okay, so this was question number D. It says that consider the following game. So it says that in this game, a level consists of n pairs of gates. Okay, so each pair contains one left gate and one right gate. And each gate performs one of two operations. One is an addition operation, which increases the number of people in a lane by a constant amount A. And one is a multiplication operation, which multiplies the current number of people in a lane by an integer A. Okay. The additional people gained from each operation can be assigned to either lane. However, people already in a lane cannot be moved to any other lane. Now, initially, there is one person in each lane, and our task is to determine the maximum total number of people that can be achieved by the end of the level. Okay, so let me explain the problem statement once. Okay, so there's a doubt with the last problem. So Naivedyam asks, can we give a formal proof why S plus low plus high is unique and not contained in any bag? Okay, Naivedyam, I think we had an almost formal argument here. So basically look S plus low plus high. I think you would agree that S plus low plus high is greater than high, right? So S plus low plus high is greater than B2n. So that means, and this is the sorted order, B2n is the largest element in the bag. So that means S plus low plus high is even larger than the largest element in the bag. So if I have a bunch of numbers and then I give you a new number which is larger than even the largest element of the bag, then is it ever possible that it will match with some other element of the bag? It is not possible, right? Like when we constructed B1 and B2, we inserted elements from the array B. And now I'm inserting one new extra element which is larger than all other elements because it is larger than the largest element, high. So high was the largest element in the bag and S plus low plus high is even larger than high. So how can it match or with any other element in the bag? It has to be distinct, right? Okay, great. So let's continue with the explanation of problem D. So the question says, as the input, so the question says that there are n gates. Okay. So first of all, there are two lanes. So let me draw them. So here comes lane 1 and here comes lane 2. So this is lane 1 and this is lane 2. Okay. In every lane, there is a gate. So every gate does something. So every gate is either of the two forms. Either it is of the form plus x or it is of the form into k. When I say plus x, that basically means that if p people pass this gate, then p plus x people come out. And when I say into k, that means if p people pass this gate, p into k, pk number of people come out. Okay. So these were the first pair of gates. Let me call them G1. Similarly, there were n pairs. So there were pairs which go one after another, and there are total of n gates. Okay. Now we have a choice here. So the question says that you start with 2 gates. So suppose these are the gates, okay, and so on. We initially start with 1 people here in the left, in the lane 1, and 1 people in the right lane. Okay. Now it says that since these gates have something written over there, some plus x and into k, the number of people will increase, right? Whenever you pass this gate, the number of people increase. Now, there were some people which originally passed. So this one person, they originally passed this gate and came out. Okay. Apart from that, some x more people got birth because it passed through the plus x gate. Similarly, what does this gate do? This gate multiplies the total number of people. So the total number of people becomes k. So after coming out, the total number of people becomes k. Out of that, 1 is original, and remaining k minus 1 more people got birth. Okay. So now the question says that this original person has to pass through this gate. He has no other choice. But these all new people who got birth, they can rearrange themselves and pass through any of the gates. Okay. So it may happen that this entire x plus k minus 1 people, they all pass through this gate. Or it may happen that they pass through this gate. Okay. Finally, the objective is to maximize the total number of people which come out. So after all these gates are passed, we need to maximize total number of people who come out. Okay, so we need to somehow smartly redistribute the people who are taking birth so that we maximize the total number of people who come out. Okay, so is the idea clear? Okay, so is the problem statement clear? Bonum, we can discuss it like after I explain this problem, because otherwise the flow would be disturbed a bit. So is the problem statement for problem D clear, guys? Okay, great. So if the problem statement is clear, so basically think about it like this, what happens? So you have some gate, you have gates here, so on, right? Suppose L people go here and R people go here. Okay. And then we had levels. So let me draw these levels. Okay, let me redraw it like this. So suppose this was my first level. So this was first level of gates. And then we have like this. This was level 2. And it goes on till there are n levels. Okay. And it says that every level has, so there are 2 lanes from which people are passing. Okay. So there are 2 lanes from which people are passing. Okay, fine. Now there are, suppose L people pass from here, R people pass from here. Okay. And then there are here there are gates which are standing, which are either of the form plus x. So they are either of the form plus x, or they are of the form multiplied by k. Any of these 2 forms the gates can be, and then there are people who are passing. Now my idea is that, okay, what should be the function? Like, let me write it like this. Suppose f of L comma R is basically the maximum number of people who can come out. Maximum number of people who can come out. If L people enter lane 1, and R people enter lane 2. Okay, so suppose this is the function. Okay, and we also need to ensure like which level are we talking about. So let me call Fk. So Fk L comma R is the maximum number of people who can come out if L people enter lane 1 and R people enter lane 2 at the kth level. So let me also write that. At the kth level. So what does that mean? So that means we have these levels, right? So this was the first level, this was the second level, and it goes on till the kth level. So this is the final level, kth level, where there are gates present. Okay, so there are gates present also at the kth level. So now what I am basically interested in that, okay, if L people pass through this lane 1 and R people pass through in lane 2 at the first level L1, then what is the maximum number of people which come out, right? So that is what I'm interested in. Like what does the question asks? The question asks to print the value of F1 1, 1. Everyone agrees? Like this is what the question asks. Like what is the maximum number of people which come out if one person enters lane 1 and one person enters lane 2 at level 1, isn't it? One person enters lane 1, one person enters lane 2 at level 1. Then what is the maximum number of people who come out? That is what the question asks. So the question asks the value of f1 1, 1. So is it clear? Like the function definition? Like we need to, the basic objective is I have defined some function and we will do something so that we can compute this function. Basically, we will try to compute this function. Like if I can compute this function, then I will print the value of f1 1, 1, and that will be the answer. But is the basic objective clear? Like what are we trying to do? Guys, a quick confirmation in the chat. Like understanding this part is crucial, because if you do not understand like what does the function signify, then understanding the later part of the solution may be a bit difficult. Okay, so I hope you all got it. So the basics, so I have defined this function and then we will try to find out the exactly what is the function is, because if I can find the function, then I will simply plug in the values of LNR to be 1 and 1, and I will set the level at 1 and I can find out the maximum number of people. Okay, fine. Now tell me one thing. Like what do you think? Like how should the function fk l comma r look like? Basically, what are you doing? Like L people pass through lane 1, R people pass through lane 2. What is finally happening? What to the number of people? The number of people is either getting multiplied with something or it is getting added with something, right? So don't you think that Fk L comma R, that should be some linear combination of L and R only? So it should be something AKL plus BKR plus some CK. Like it should be of this form, right? It should be of this form. Like where A, B, and C are coefficients basically. Like it cannot, like this function L comma R, think about it. It cannot look something like, say, some coefficient AK into L square. It cannot look like that, right? Because what are you doing to the number of people? Like what happens to the number of people? You basically multiply it with something or add it with something. So what you at the end of the day you will get will be something linear, right? So these type of things are not expected. So that means the function fk l comma r will look like this form. It will be of the form akl plus bkr plus ck, right? So that means what suffices to find is the values ak, bk, and ck. That is we are interested, right? Finding the coefficients. Like what will be the coefficients ak, bk, and ck? If we can somehow find that, basically the entire function description is known, then we can simply plug in the values of L and R to find the final answer. Okay. So we basically need to find the values of AK, BK, and CK. Okay, great. So let me again try to draw the stages. So I have these levels L1, L2, and it goes on till Ln. Okay. At every level, I have two gates. So at every level, I have two gates. And it goes on. And every level I have 2 gates. Fine. Now at the kth level, LK, so this is suppose the kth level, and if L people enter lane 1, R people enter lane 2, then what is the maximum number of people who can come out? That is given by my function fkl comma r. And my claim is that this function fkl comma r, for any k you pick, you start from 1 or till n, for any k you pick, this will be some linear combination of L and R. Fine. So now let me try writing the base case. Okay. So, okay, fine. So let me try writing the base case. So here, this is the nth level. And suppose these things which come out, let me call this the n plus 1th level. Okay. So the people which come out is the n plus 1th level. So can anyone tell me what should the function f n plus 1 L comma R look like? Like what is this function? Basically, up to the nth level, we do not know what is the maximum number of people who will come out. But at the n plus 1th level, do we know? Like what should... Okay, so what subscript 1 means in L1? Okay. So this subscript means what is the level? Basically, you have n gates, right? So this is the first pair of gate. Then you have the second pair of gate. This is the third pair of gate. This is the nth pair of gate. Okay. Now, at every level, my function will be different. Like if I start from here and I ask you that, okay, if L people go here, R people go here, what is the maximum number of people? What is the maximum number of people who can come out? Then that answer will be different than if I ask at some other intermediate layer, L and R, and what is the maximum number of people which will come out, right? So that means I have n functions. I have function for each level. Like for every level, the function is different. Basically, the coefficients will vary at every level. Okay. So that is the reason the subscript basically defines which level are we talking about. Because if you change the level, then the function changes. How many maximum people come out on the same L and R changes. Okay. So now this is a simple base case. I am saying that, okay, at the n plus 1th level, there is no gate, right? At the n plus 1th level, there is no gate. So at the n plus 1th level, since there is no gate, then if L people enter lane 1, R people enter lane 2, then what is the maximum number of people who come out? That would be simple L plus R. Nothing else, right? No other, no other gate transformation is there. So the number of people who enter, those only come out, right? So what are the coefficients? Look, that L plus R is also a linear combination of L and R. So if you try to compare it with A n plus 1 L, I initially claimed that any function f k L comma R would look like this. It would look like this, some linear expression of L and R. So here for n plus 1, I have already shown that A n plus 1 is 1, B n plus 1 is 1, and C n plus 1 is 0. Isn't it? Like this is 1, this is basically 1 into L plus 1 into R plus this is 0. Okay. So up to this, is the solution clear? Like any doubts, please ask up to this, because like if you have understood this part, like what is the function description, then the rest of the solution will smoothly follow. But if there is some doubt, even the minute of the doubts up to this part will create confusion in the later part. So please clarify if you have doubts up to this, or at least confirm if it's clear. Like, is it clear for everyone? Okay, great. So now we know function f n plus 1. Okay. And finally, what is the answer? We need to finally find this function f1. Okay, we need to finally find the function f1. We know the function fn plus 1, that is L plus R. We need to find the function f1. So that means we need to go in reverse order, right? So what should be my order? I should go from f n plus 1. So I know f n plus 1, this is known to me. And here is f1 sitting, which is unknown, which is basically my objective. So what will you do? We will try to go in reverse order, and we'll try to find all these functions, in between functions. Okay. And so on. If we can find all these functions, then we are done, right? So we will write a reverse for loop, and we will assume that, okay, if k plus 1 is known, and from there we will try to find if k. That is the basic idea of dynamic programming, right? We know what is the function. Suppose we know what is the function f k plus 1. So if k plus 1 is known, and from there we will try to write f k. So that is my basic idea. Okay. So here f n plus 1 is known, and we will try to first compute fn. Then fn will be known. We will try to find fn minus 1. And by this logic, we will finally get to our objective f1. So that is my basic idea. Okay, fine. So now think about this. So this is my kth level. So now I have zoomed that picture. I am thinking about only 2 levels. Okay. So here there are 2 gates, which I do not care much. I know the function fk plus 1. So the function fk plus 1 is known. So the function, suppose the function fk plus 1 L plus R, that is known. That is suppose that is ak plus 1 L plus bk plus 1 R plus ck plus 1, right? And suppose this ak plus 1, bk plus 1, like what do I mean when I say that this function fk plus 1 is known? That basically means I know the coefficients ak plus 1, bk plus 1, and ck plus 1. All these 3 are known. Now I will try to find out the coefficients ak, bk, and ck. That is my objective, right? So here comes the gates of the kth level. Okay. And L people enter lane 1, R people enter lane 2. Okay. I need to find what is the value of fk L comma R. I know fk L comma R would be something of this form, akl plus bkr plus ck. So what remains to find is the values ak, bk, and ck. Okay, great. Now all these gates, now there are these gates. Let me think about that. All these gates are of this format: into some value f1 plus some value c1. Now you will ask me, okay, why did you complicate it? Like, why are you taking, like, every gate is either of the form plus or of the form into, right? Then why should we take into f1 plus c1? I'm doing this just so that I do not need to handle a lot of if-else conditions. I would think every gate like this. So basically, if I have a gate of the form into x, I can think it like, okay, if my f1 is equal to x and my c1 is 0. So this can be equivalently think of it like this. And if I have some gates, say, of the form plus k, I can think, okay, that basically means my f1 is 0 and c1 is k, right? So every gate I will think of this format: into f1 plus c1. Okay, fine. So now let me redraw that. So I have this lk, and corresponding to lk, I have 2 gates. The first gate is into f1 plus c1, and the second gate is into f2 plus c2, right? And then some people will come out, and finally they will enter this lk plus 1th level. Okay, for this lk plus 1th level, the function if k plus 1 L comma R, which basically means the coefficients a k plus 1, b k plus 1, c k plus 1 is already known. So this is the function. Okay. Now L people enter, like L and R people enter these lanes, right? So how many people come out? Think about this. So what is basically happening? So there are 2 gates. L people enter here, R people enter here. right? And these gates are of the form into F1 plus C1, and this is of the form into F2 plus C2. Okay. Now, as the question suggests, these L original people will definitely come out, no doubt. So these L people are original, they will definitely come out. How many new people will take birth? How many new people will take birth? Can anyone answer this in chats? So how many new people will get birth? Yeah, Aniketa, 3D memoized implementation probably will also work. Like, depends on how you implement the logic. Okay, let me write this down myself. So out of these L people, if I pass it through this gate, then what would happen? Like, the number of people will become F1L plus C1, right? So this C1 new people will definitely come, like this is the constant factor. Apart from that, an F1 minus 1 times L people will also come, right? Similarly, here C2 people will come out, they will take birth, and these F2 minus 1 times R people will come out. So up to this, is it clear? Like, is it clear up to this? A quick yes in the chat. Like, any doubts up to this? Okay. So I assume that there are no doubts. So now what I'm doing is, okay, let me get rid of this minus 1 and think of this as a plus 1. Okay, so let me think this as F2, F1 plus as F1 plus 1 and F2 plus 1. And let me write this as F1L and F2R. This is just for implementation. You could have done a different way too. Okay. Now, these people have to go, right? These L people have to go through lane 1. R people have to go to lane 2 as per the question. They have no choice. Now, these all people I can rearrange. Okay, fine. Now, I already know the function fk plus 1. I already know the function fk plus 1 L comma R, right? What is that? That is ak plus 1 L plus bk plus 1 R plus ck plus 1. So I know what is the maximum number of people who will come out if L and R if people go through lane 1 and lane 2 respectively in the k plus 1th layer. Okay. Now there are two cases. Let me start with the case that ak plus 1 is greater than bk, greater than equal to bk plus 1. The other case is exactly symmetrical. Okay. So let me start with this case. So if ak plus 1 is greater than equal to bk plus 1, so that means it is beneficial if all the people who have freshly taken birth pass through the left lane. Because if they pass through the left lane, the value of L will here increase. And if the value of L increases, then since the coefficient of L is larger, ak plus 1 is larger than bk plus 1, it will be beneficial. It will maximize the number of people. So that means if ak plus 1 is greater than equal to bk plus 1, it makes sense that I force all these people who have taken newly birth to pass through the left lane. Okay, so that is my idea. So let me write this. So if that happens, so what is the value of fk L comma R? Fk L comma R, that is how many, if L people pass through the lane 1, R people pass through lane 2, how many maximum people can I get? That is simply, now what just happened? Under the assumption that ak plus 1 is greater than equal to bk plus 1, what just happened? All these people, L, C1, F1L and C2, F2R, they all passed through left lane, right? So it would be ak plus 1 because things are entering in the k plus 1th layer, and L plus F1 into L plus F2R. These many people pass through the left lane. In the right lane, how many people passed? Simply R. No one else passed. Okay. and then we have a ck plus 1. So basically, I know fk plus 1. I am trying to write fkl comma r as in terms of fk plus 1, isn't it? Just I'm correctly plugging in the values, how many people pass through these k plus 1 regions, like pass through the k plus 1th layer. And I say that, okay, since the coefficient ak plus 1 is greater than equal to bk plus 1, so all these people who have taken fresh birth pass through this region. Okay, this C1 and C2, sorry, I just forgot about this C1 and C2. They also pass through AK plus 1, right? So let me erase this. So let me add a C1 and a C2 here. Okay. Now I need to rearrange them to find the coefficients AK and BK, right? So anything which is attached with L is AK, right? So let me separate this and let me write it like this. L into AK plus 1 times F1 plus 1 plus R times BK plus 1 plus F2 times AK plus 1 plus, and here comes the constant term, CK plus 1 plus AK plus 1 into C1 plus C2. Note that what we did, we tried to compute an expression for FKLR in terms of FK plus 1 LR. How I did that? I basically, first of all, I just simply counted how many people come out. And then since AK plus 1 is greater than equal to BK plus 1, everyone has to pass through the left lane. And I already know that, okay, if everyone passes through the left lane, I already know the function fk plus 1. I put it into the function fk plus 1. That means I took help of these coefficients, of these k plus 1 coefficients, to find out the coefficients for fk. Okay. Now if you see clearly, like what, this is my AK. Anything which is attached with L in FK, that is AK, right? So this is my AK. This is my BK. This is my BK. And this final term, this is my CK. So using this expression, so let me rewrite this expression. So what is AK? AK is AK plus 1 times F1 plus 1. BK is BK plus 1 plus F2 times AK plus 1 plus F2 times AK plus 1, and CK is CK plus 1 plus AK plus 1 into C1 plus C2. So CK is CK plus 1 plus AK plus 1 times C1 plus C2. So I hope you got the idea. I knew the values for AK plus 1, BK plus 1 and CK plus 1. I used them to find the values for AK, BK and CK. So I can just run this loop in reverse order, and finally I will find out the values of A1, B1 and C1. Okay. So if I find out the values of E1, A1, B1 and C1, so I would get the function F1L comma R, which is A1L plus B1R plus C1. And now, since I need to find the value of F1 1 comma 1, that would be simply, you just plug in L equal to 1 and R equal to 1 here, and you get the values A1 plus B1 plus C1. That is basically the sum of the coefficients, which will be my answer. So any doubts with the solution? Okay, Aniket, let me quickly go through the logic again. So the logic is simple. See, what will I do? I have called the function, like I have defined fkl comma r is basically the function that how many people, maximum people pass through the last layer, if like how many maximum people finally get birth if L and R people pass through the kth layer. Okay, that is my function fk. Now any function fk can be easily defined using the three coefficients ak, bk and ck. So now I have my base case clear. So my base case values I already know. Just a second, where did I write? Yes, exactly. So here, if you see, I know the values of base case, values of my base case. So this is my base case. So that means I know the function fn plus 1. I know its coefficients. I want to find the coefficients for f1. So I'm going back in reverse order to find the coefficients for f1. And now the idea is simple. So that means what will I do? I will use the coefficients for the function fk plus 1 to find the coefficients for fk. How do I do that? The idea is simple. I basically look that, okay, if I need to compute fk, right? Fk L comma R. So that means how many people maximum I can get if L people pass from here and R people pass from here. So now I try to write the dynamic programming transition. Okay, if L people pass from here, R people pass from here, they first of all get out of this gate. So how many people get out of this gate? I get this idea. Now, the best part is that I know the function fk plus 1. When I know the function fk plus 1, I know the coefficients ak plus 1 and bk plus 1. Now, if I know the coefficients ak plus 1 and bk plus 1, I can check which one of them is larger. And by that way, I can decide that all these people which have newly taken birth, which lane should they go? Should they go to the left lane or should they go to the right lane? Depending on that, I use that expression, and then it's a bit mathematical. I use that expression to find out I know the function for ak plus 1. So I use those coefficients ak plus 1, bk plus 1, and ck plus 1. I inserted those exact same values of how many people enter here into these expressions, and I find out the coefficients ak, bk, and ck. Okay, so if I find out the coefficients ak, bk, and ck in terms of ak plus 1, bk plus 1, and ck plus 1, so I can use that in reverse logic to actually find the values a1, b1, and c1 and get to the answer. Okay, so let me show the code once. So here is the code. So I first take these, basically I take all the gates as input. So the characters are present in OPL and OPR vectors, and L and R vectors basically consider compute the integers. Okay, and then I have these basically factors and bases. So this is basically my like f1, f2, c1, c2 values. Okay, and now this is my base case. A equal to b equal to 1, c is 0. So these are the coefficients of the fn plus 1th function. Okay, now I first of all scan the ith gate. So I'm traversing reverse order n minus 1 to 0. I first of all scan the gate and populate these values f0, f1, c0, and c1. And after that, I use the same coefficients as I discussed. Okay, so if you look at this, so these are basically the same expressions which we found out. So a into 1 plus f0, b plus a into f0, and so on. So using that, I use the coefficients of the fk plus 1 function to compute the coefficients of the fk function. Okay. So using this, I finally find out, I do this in reverse order to finally, finally a, b, and c gets populated with the coefficients of f1 function. I compute the sum and print it. Okay, so is it clear? Or any doubts on the solution? Okay, so if that's clear, so if there are any doubts on even the previous problem, then you guys can ask. Like someone was asking a doubt on C. Okay, so if there are no doubts, then thank you. That's all. That was all from my side.